So it looks like we're good? Yeah. So today I just wanted to try and see about doing this stream thing. Wanted to talk about a little bit of calculus here. One topic that I see people struggle on with is I'm nobody's even here. Basically, yeah. Let's see if it's actually working. Um, let's go to YouTube and let's see here. Let's go to here. Let's go to here. Yeah, can you hear me? Okay. Oh, it looks pretty good. Concavity is a function of, yeah, helps more if you do it like this, but if you're looking through the live, hmm. All right, so just wanted to look at this and say that, man, I don't know. Okay, well, let's just see if anybody drops in. Hopefully somebody will. Um, but I don't know. Can I like see a chat or something? I don't think so. Um, well, does it like actually stream to everything? Let's see if I'm streaming on Twitch because I wanted to hit browse, hit here. So no, I'm not streaming on here on Twitch, but I don't know how to do both. Anyway, concavity is if a function is shaped down, right, or shaped up. It's like just the bowl that you're looking for. Um, the point at which the function turns from concave up to concave down, right? Um, turns from concave up to down or vice versa is known as a point of inflection. Now, you could see here where it's like I drew a graph, and the main thing to take away is You do have concave down, right? So concave down is just like if you have the bowl going upside down, and concave up is just the other way, right? The point of inflection is where it turns from uh, right side up to upside down. Okay, so let's talk about a little bit what we're going to see today. This is the method. The method to find each is to take the first, second derivative of a function. Okay? Now this is assuming everybody knows how to take the derivative of a function. Just basically you're going to use, for the most part, power rules. There's some tangent things that we need to look at. So be sure to be brushed up on those. um, if the second derivative of the function is positive, then it's going to be concave up. And if the second derivative of the function is negative, then it's going to be concave down. Okay, so we've got set the second derivative equals 0 and solve for x. Set up a number line and test values for positive or negative before and after the inflection point. Now, you're setting it to be before or after the inflection point to set it up like this number line to test the second derivative values that you set to 0 and you found. Um, and these would be the critical points for those. So that way we could check inside that range if there were multiple values. Sometimes you're only going to get one, sometimes you get two, sometimes more. It's just depending on how high a degree the function is. And then that'll tell you how many points you're going to need to check to see, because you might have multiple inflection points here, right? Um, I wrote critical point, but it's actually inflection point. The critical points are from the first derivative. One cool thing to note is you'll see that it's positive on one side and negative on the other in between, after, before and after a inflection point. And what that means is that you're going to have always a change in concavity, right? Versus after an inflection point, excuse me. So on the left it's concave up, in the middle it's concave down, and on the right it's concave up. Okay, so let's look at an example here. So as you notice, we've got this function with the fourth degree. Um, if we say here that if x to the fourth plus 4x to the third, right, minus 48x squared plus 40x minus 22, and we just want to know which interval or intervals is the graph of this function, concave up. Okay, so we know that we need to take the second derivative, so then that means we're going to have a degree of blank, right? Which we're going to be solving for answers. We're going to have two answers, right? Because you're taking two away from the highest degree. So it should be x squared. X squared means that you're going to have plus minus one number. And then you'll be able to test the interval from there. Okay, so it looks like we could just go ahead and just set up and do a power rule. Um, as far as like something to do like um, up, down, or whatchamacallit, um, the fourth to the Oh man. Shit. God, I am tired. It is 11:30. Well, at least I know it works, right? I mean, I guess it could be a little bit louder, right? So let me go ahead and let's change that. Make it a little bit louder. Yeah. Oh, testing. Testing. Yeah. Maybe that's better. Okay. Yeah. Well, basically, I just wanted to go ahead and have it just a little bit louder because I wasn't able to hear too much. But maybe I can go ahead and just keep it up a little bit more. Yeah. Well, I'm not going into yellow or anything. I'm just setting it up so that way I can. Yeah. Okay. I think that's better. Let's see. Let's see what that sounds like. Because again, this is all just like a test. Maybe is that good? Well, I'm not going into yellow or anything. I'm just setting it up so that way I can. Yeah, okay, I think that's better. Yeah, I think that's a good. This is all just like a test. Okay. Yeah, I think that's good. Um, I mean, I could even turn it down just a little bit down to there. Okay. Yeah. So power rule looks like for everything. So the derivative should be 4x cubed plus 4 times 3 is 12, x squared. 48 times 2 is 96x plus 40. And the derivative of constant is 0. And that's what we have, right? Luckily, we're only going to do a second derivative, so 4 times 3 is, let's go ahead and take the derivative of this derivative. Um, with respect to x again, uh, obviously, but it would be 4 times 3 is 12, x squared plus 24, x minus 96. Okay, and from here we're going to do what? We're going to go ahead and set this function equal to 0. Holy crap. I have just yawned like 6 times. Set it equal to 0. Um, just look for factors that you can go ahead and pull out to make your life a little bit easier, you know? Um, what is that? 12s can come out. So should be 12 times parentheses x squared plus 2x minus 8. Yeah. Yeah, you could divide by 12. 0 over 12 is 0. You're left with this. This is actually factorable, right? Positive 4 and negative 2, right? So it'd be x plus 4 is a factor and x minus 2 is a factor. We can go ahead and write that in factored form. Thanks to the zero property rule, we'd be able to show that we can put these each separately equal to 0 and solve for x. Uh, Meaning that x plus 4 is equal to 0. Subtract 4 on both sides. You get x alone. You get x is equal to negative 4 and x minus 2 is equal to 0. Yeah, alright. I'm going to call it. So once you do this, you set up the number line. And then you just plug in numbers, right? Before and after the inflection point. So in this case, -5. Um, you just plug it into the second derivative question and see if it's either positive number or a negative number. That's all you really care about. Um, and do the same thing for the second interval where I chose 0. And for the third interval, I chose 3. So again, I was able to solve for 2 because 2 inflection points because it was x squared, right? So I'm going to be solving for that. Answer is +1, and which makes 3 areas to solve for. That's it. The function is concave down between this interval of -4 is less than x, which is less than or equal to 2, and concave up from -infinity to x, which is less than -4, and, or union, 2 is less than x, which is less than or equal to, or less than positive infinity. And that's displayed right here for us to see again. And it's just written out in words because you always want to try to use something that's going to be adequately available to understand like a statement, right? So it shows definity. So I'm going to stop it here. So thanks for listening.